Hello, senior project students, or at least the ones who are working with me. Specifically, I think the material that's relevant is specifically for Tong, Parker, and Ariana. Uh, I might go ahead and share this video with the rest of the VR class too, because there is some interesting stuff in it uh, that is helpful tidbits to know for later on maybe. And if I do that, hello rest of the VR class. For the rest of this video, I'm ignoring you guys and talking specifically to the senior project students who need this specific material for their specific projects. Okay, so what you see here, you know, informal video by the way, just to be clear. So what you see here is a basic Unity environment just for kicks and grins. I've included a couple objects in here, one of which is really important, this plane, and you'll see that in a minute. Parker in particular, this plane is going to be interesting for you a little bit later on because we're going to make it do magic stuff. But the rest of this is in here just so we have something to look at when we put the headset on. Okay, so first, there's nothing special about this environment. You're not going to be using this like we developed for the VR class, okay? So for the VR class, I had those specific set of instructions where you go and you set this option, that option, this option, that option, and build for Android. For your projects, you're not going to be building this over, building this to run mobily. You're going to be building this to run as a tethered display using Oculus Link. So that actually makes life a lot simpler because the default settings when you make the environment are pretty much just going to work. Just be sure that you're building for Windows. I think all three of you guys are building for Windows, so make sure you're just building for Windows. Check your build settings, make sure this is selected, make sure this is selected. Other than that, you're good. The only other thing you have to do is import your Oculus integration. Same Oculus integration package that you have got to import for your mobile applications for the VR development class, same thing. So once you've got your OVR camera rig in there, this is where the interesting stuff is going to be happening. Okay, or some of the interesting stuff. So Tong and Ari, for your projects, you're going to need to be capturing and processing controller positions. And there's a couple different ways to do that. The way that's going to be most straightforward for you is to, write a script. You'll have to write a script one way or the other, but the most straightforward way for you to do it for your project is to write a script and apply it to an empty game object that'll act as your sort of, we'll call it a tracking liaison. It's going to get the information from the tracked objects and then send that with code that you write, not what I'm showing you today. I'm showing you how to get the information that you want to send. There's a difference there. So you're going to have to write the rest of your framework based on top of this, what I'm about to show you. This is just how you grab the information. That's the cool thing about APIs. They open up mysterious bits of hardware to you or other mysterious bits of software and let you grab things in a way that is familiar that you can then process with your own code and send to somewhere else or do something else with it. Okay, so keep that in mind. I'm not showing you what to do with the data. I'm just showing you how to get the data. That's important. Okay, so what I would recommend that you do is in your scene create an empty game object. And so we can, sanity check ourselves later on and know what all the things in our scenes are doing. Give it a meaningful name. I'm just going to call this capture tracking object. Kind of straightforward because what you guys are doing with your projects is you're going to be capturing the motion capture data from the controllers to send somewhere else. Or for Ari in particular, to send somewhere else, to send to your Python program that's going to be doing the other tracking stuff for your outside animation. Tong, for you, you're going to be using the positions of these to position other things. Hypothetically. There's different ways to do it, but this will get the ball rolling for you. Okay. But by itself, this game object doesn't do anything. So you've got to make magic happen to it, attach something magic to it. And that magic thing is a script. Okay, so we want to, actually, can we back this up? Yeah, okay. So you want to click Add Component. Make sure that your game object is selected. Click Add Component. And then scroll down to the bottom and go to New Script. And we're going to call this, just call it Tracking Capture, just for simplicity's sake. And create and add. And boom. Notice now over here we have a C# script inside of our assets folder called trackingcapture.cs. Okay, and it starts you off with some basic stuff. Let me actually open this up in Notepad++. Okay, so let me put this here and put that there, and boom. Okay, when you make a new C# script in Unity, it's just going to give you this basic framework. It's got the basic stuff you need already set to be imported. There's important functions. So the start function only runs when you start your environment. More specifically, when that object is instantiated in the environment. Subtle difference. Effectively, when you start the environment, that function runs. Next thing that's really important is the update function. You know what, I'm almost definitely going to share this with the whole VR class, because this is going to be helpful later on, and for your projects. The next thing is the update function. The update function is all the code that you want to happen on a frame per frame basis. Because when you're watching stuff happen in the headset, or you're watching stuff happen in a video game, it's individual pictures essentially that are being put on the screen. And so every time it updates that picture, oversimplification, every time it updates that picture, it's going to call this update function. So it says, okay, before I update this picture, let me update all the things in our scene and call the update function, then put the picture on the screen. Technically, this function happens more quickly than what gets displayed on your screen. And that's not a bad thing. Yeah, once per frame. It's not once per frame. It's, well, sort of. It's complicated. For simplicity's sake, we're going to say this happens one time per frame that's displayed on the screen. Okay. So what we're going to want to do is, I want you to make this, if you use this pattern, you want to make this as generalizable as possible. So we want to make a game object. So everything in Unity, even your controllers and headset, inherit from the game object class. So they're game objects. So let's make a game object, and we'll call it right_controller. And we'll save it. Well, let's go over here to Unity and click on our capture object. Yeah, now you see that the tracking_capture is attached to that object. That's good. But you want to be able to interact with your script sometimes without having to hard code stuff in here. What we can do is make this a public game object, save it, go back to Unity, wait a second, and look, there's now a little dialogue here that says right controller. Oh my gosh, that's the same name as our variable. That's because it's the same thing. And when you get a little box like this, that means you can drag stuff into the box. So if you've been exploring in your OVR camera rig, which hopefully you have, you'll notice that it's got something called your tracking space. It's got a left eye anchor, a center eye, that's your cyclopean eye, center of your head. Your right eye anchor, a tracking anchor, and, oh my goodness, a left hand anchor and a right hand anchor. These are the things that update, their positions update as you move your controllers through the scene. So what we want to do is, I want us to track the right hand controller. So let's click on our game object. See, we've got right controller, none. We can click over here and drag the right controller anchor into that box. Boom. There's our right controller. Now, inside of our script, every time we reference right controller, the variable, we're referencing the game object that is our right-hand controller, meaning we can get all of the nifty information from it that it's providing. In your case, you're interested in the positional and rotational information of the controller. Okay. So game objects have a member called transform, and that transform is the 3D transformation that's applied to that object. So in other words, it's the place you look to get its position and its rotation. So if you want to output text to your debug console over here, let's clear all these things. There's a function you call called debug.log, and you can put text in there. Let's save that and just run it over here so you can see it putting stuff out on the screen. Oh no! Oh, is it capital L? Might be a capital L. Probably a capital L. Let's run it. Yeah, okay. So now, you see it's just outputting a bunch of ASDFs, ASDFs, ASDFs. Okay. Cool. But I want us to see the position of that right controller. Well, here's what you do. Right controller dot transform, and that's the data structure that contains the positional and rotational and scale information of the game object that you're talking about. In this case, our right controller. That was actually our left controller, our right controller. So what we can do is we can print right controller dot transform dot position. Okay, and what this will do, it'll print a 3-element array, a vector, a 3-element array, a vector 3 is the specific data type. So a 3-element array that is the x, y, and z components of the transformation. So it's position in space, in 3D space, x, y, and z. So let's clear our dialog here, our console, and let's play this, and let me get the headset. So I've already got the headset on. Let me just hold, hey, see, it's got a little preview there. Let me grab the right-hand controller. Let's go down to the bottom here, and look, the numbers are changing. Oh my goodness, isn't that amazing? Yeah. So that's how you get the 3D position of the controller. Now, you guys are probably also going to want to access the 3D rotation. So there's a couple different ways to do that. The obvious way is to do this. See that? See what I did there? Change position to rotation. And then we could click play. Okay, so let's let that play. There we go. And let's scroll down to the bottom so you can see everything. And look, oh my goodness, that's amazing. Except, notice that there are 4 numbers there. Wait, rotations are along X, Y, and Z. Why are there 4 numbers? Oh my goodness. Well, that's because rotation, transform.rotation, reports the rotation in a format called a quaternion. Quaternions are actually great. They're outstanding ways to represent rotations, and on top of that, they were developed by an Irishman. My family's Irish. My mother's a Finnegan, specifically. Anyway. But here's the thing. Quaternions are counterintuitive. Well, let's not say counterintuitive. They're not super easy to parse by a human anyway. Just looking at it, trying to figure out what the rotations are. So sometimes you actually want to know the lesser of the rotational options, the one that's more intuitive for you, the human coder. If you're applying these rotations from one thing to another, keep it in quaternions. they're functionally better. We can talk about why later, but they're functionally better. But if you want to debug something and you want to see it in X, Y, and Z rotations, you're interested in Euler angles, not quaternions. So transform dot Euler angles will give you another list of 3. I've been working in Python a lot, so I said list as opposed to an array or vector. So let's play this. And you can see the latest output to the console there, but just for simplicity's sake. Now look at that. Those are 3 floating point values, all oscillating somewhere in the range of 0 to 360, which is what you want to see if you are used to looking at it in those terms. Okay, now here's the real talk. The real talk is I have just shown you how to print a variable to the screen. To be in the VR class or the data science class, which all of you have taken at some point or are currently in, you have to have had, like 3 semesters of programming prior to getting in here, which means you know how to treat a variable. So I'm not going to, spoon feed this particular process to you. You guys know how to treat a variable. You can reference individual elements, using indices or whatnot. There's actually another nifty way to do it in this. You can actually reference it by .x and .y and .z to get the components out. But at the very least, you're familiar with the numerical index notation like this. Okay, so this will let you get access to those variables. Now it is up to you to do something interesting with them. Okay? You can also reference the transformation matrix itself. For what you're doing for your projects, I don't think you're necessarily going to want that. Tong, maybe you'll want that. I'll let you make your design decision there. I'm not going to micromanage that one, but be aware that it's there. Also, I strongly encourage you guys to spend some time looking at the actual API documentation for Unity when you're doing these things, because Unity's documentation is actually pretty darn good. So tons of information. If there's something about the transformation that you want to, or the Unity transform that you want to look up, just check it out in their API documentation. It's really good. So strongly encourage that. Okay, so there's the first bit of magic, specifically for Ari and Tong. Parker, you have a different set of magic. For your senior project, you are going to want to render a camera to a texture, which is kind of cool. I've been doing this long enough to be able to say that, there was a point in time where render textures were genuine magic. And you had to be certain of what GPU you were using and what driver you were using. And there were other weird little bugs, and man, rendering to texture and copying that into a place that could be actually used as a texture was non-trivial, and it was frustrating, and it was annoying, and bug-ridden. If any of you are thinking, well, that doesn't seem like, yes, it was like. I've been doing this a long time, and it wasn't always terribly easy. And just as we've had some, we'll call them difficulties, minor frustrations, sometimes major frustrations, getting the development environment to work with this headset, those are tiny inconveniences compared to some of the some of the GPU specific bugs we had to deal with back when there wasn't Unity, you know, and you were writing all this in straight C, um, and writing your own shaders, or before shaders were even a thing, because there was a time that was a thing. Anyway, if you don't know what a shader is, don't worry about it. Take the graphics class. Tons of fun. Okay, so Parker, your thing. Okay, so we can get rid of this, and let's just make this nice and full screen here. Okay. So over here in the scene, I've added some objects. Mostly just so we'll have something to see when we put the headset on, just to sanity check to make sure that everything is working properly. The one that you're going to want to care about is this plane right here. So we're going to do a magic thing. So for your part of the project, what you're doing is you want to have a virtual camera that's rendering its images to a texture. And then we want to put that texture on a plane, almost like a virtual TV screen, like a virtual monitor. Well, this is easier than it used to be. There's actually a game object in here called create render texture. Okay, you're going to want to create that, and we'll just, for simplicity's sake, call it camera texture. Okay, so that's step one. Next thing is you need a camera. So what we're going to do is you're going to make a virtual camera that, instead of rendering its image to a screen like, you know, what we've got here, we're going to render it to memory and use that image rendered to memory as a texture, like you would texture map, you know, a picture onto a plane or something like that. You're texturing this live stream of images coming from a virtual camera. So let's actually attach a virtual camera to our controller, and that'll make it kind of fun because we can wave it around. And remember, you're doing a simulated augmented reality application, not a real augmented reality application, but you're simulating augmented reality in virtual reality. So, you know, attaching it to a controller or something like that doesn't seem terribly outlandish, at least for debugging purposes or testing purposes. So let's right click here and let's create a camera, and let's just give it a name. Let's call it our sim AR camera, just to keep it simple. Okay, so if we click on that over in the inspector, you know, we've got a lot of, you know, options that, you know, we can leave most of these pretty much where they're. Depending on what we're doing, you might want to play with the near clipping plane because we might want to look at things really close. But, you know, I'll let you make that design decision as you get there. The other thing that I want you to look at is there's something called target texture. And just like with the script that we wrote for Ari and Tong to illustrate, you know, getting the transformation information, it's something you can drag an object into. Well, here's what we do. We go down here and we click our camera render texture that we just made, and we drag that into the target texture. Boom. And so now we've got a virtual camera attached to this controller, okay? And as we're moving it about, its camera view is being written to this image, and then we can use that image as a texture on something else. So what we can do is we can just drag this texture, for instance, onto another object, like this guy right here, this plane. Cool, right? Okay, so let's run this environment and show you what happens. By the way, a variant of this is what they use to do mirrors in video games. So there's another camera like located at the mirror that's looking out, capturing the image, and then it's being texture mapped onto the mirror surface. There's some other math involved in that. It's not just straight this, but this is the starting point for those kind of mirror effects. Okay, so let's start the scene. You should get the preview over here. Okay, let me grab the controller. Okay. Okay, cool. So I'm moving the controller around, and you can see the camera that's attached to the controller, its view is being mapped onto that plane. You know what? Let's make this a little more obvious, because the controller model isn't in the scene, because by default it isn't. You got to add that. Let's add that so you can actually see where that virtual camera is located. Okay. And this will be the right touch controller. Oh, and for those of you who weren't watching, and it's okay if you weren't, what we did to get the model of the controller in the scene, went to Oculus, VR, prefabs, and then there's an OVR controller prefab. You can drag that onto your controller anchor, and when you do that, you can bind the buttons to like different things, but to make the model appear correct, you want to go to controller and then select the specific controller that's attached to that hand anchor. In this case, these are the touch model controllers, so we're going to use the right touch. There we go. Okay, so let's play this again. Okay. And there it is. Whoops. There we go. And look, I'm pointing it up there, I'm pointing it over there, I'm pointing it over there. And look, oh my gosh, the camera view is being mapped onto that texture. Okay, so that's going to get you a lot of mileage for what you're wanting to do. And yeah, I think that covers the get you started bits of information for the next stage of your projects. If you have questions about any of this, let me know. Don't hesitate. I'm here. I want to help. But this is your senior projects, so this is you playing the role. Actually, more than playing the role, you're embodying the role of a professional developer. And so, I'm giving you some tips here, but yeah, you're the folks out there developing these assignments. Actually, they're not assignments; they're products. You are developing a product, and that's the purpose of what we're doing. So yeah, go out there, go forth, take these tidbits of information that we got today, and use those to springboard the next part of your project. For our senior project meeting on Friday, don't forget 3:30 Friday, senior project meeting. At the very least, have these implemented, preferably a little bit on top of that. In particular, let's see, Ari, for your project, you're going to want to eventually get this out to an external program. I think we talked about doing that over the loopback address. If you can go that extra step, do that, or at least get started in that direction. Maybe doesn't necessarily have to be working on Friday, but take a step in that direction. Tong, you were integrating Google Poly or something else to come into the environment. If you can, manipulate those objects in the camera pass through scenario we're talking about, show that. At the very least, get the transformation information out, both of you. And Parker, I think you might have already gotten close to, maybe already at the part that I showed you today. I'm not really sure. But if you hadn't, at least get the render to texture working, and look into culling out objects, because we want to have an augmented reality simulation in VR, meaning there needs to be some objects that the headset won't be seeing, that our augmented view that you're controlling elsewhere will be seeing. You're gonna want to look at layers. So layers are going to help you with that, and in particular, yeah, layers and culling masks. Those are your hints. You can figure the rest out from there, but those two things are going to be very important to pulling off the stunt that you're going to need to pull off to make the simulated augmented reality work. Okay. With that said, I am late for family supper, so I'm gonna wrap this up. I hope you're all doing well, staying happy, healthy, and safe. Stay warm with this bizarre winter weather we're having, and temperature's supposed to go up by like 40 degrees from this week to next week. So yeah, at least it'll be a little bit warmer. It'll probably be wet and nasty since we've got multiple inches of snow and ice outside, but it is what it is. Anyway, take it easy, and I will catch you in class.